Hi, this is the first video that I'm making after all the changes that coronavirus caused. So I'm going to have video clips. As soon as they're ready, I'm going to send you a link. And also, I'll try to have a video for every chapter from now until the end of the semester. I hope everybody is well, at least okay, with all the changes that we've gone through. But I'm sure we can get through this semester and finish it together. Now you can always ask questions, of course. You can via email, and I'm going to send scheduled Blackboard collaborates that you can participate. And also I'm going to send you links to videos you can watch. I have moved due dates for the tests, and then it should provide you enough flexibility to take the tests. But as I said, if you have any questions or problems, just email me. Now I'm going to start reviewing chapter 7. I'm going to go over basic concepts in chapter 7, and then I'll do some problems from Newton Alto side. So first thing I'm going to do, I'm going to get rid of my video. I don't think you need to see me. And then I'm going to start with basic ideas from chapter 7. Now in chapter 7 we talked about central limit theorem. With central limit theorem, the main idea was that if you have a population like this one and you wanted to take samples from it, well, if you take samples from a population of size n and keep doing so, then and calculate the mean for each sample, then the distribution of the means of the samples will have approximately a normal distribution with the mean of this population the same as the mean of the population that the samples come from, and the standard deviation of this distribution, which is called the sampling distribution of sample means. The standard deviation of this distribution is the standard deviation of the population divided by square root of sample size. Now we also talked about the fact that, well, the mean is not the only thing you can calculate from the sample. You can take samples and calculate the sum of the samples. Let's say we wanted to, we are interested in the average height of San Jacinto College students. Then we take samples and calculate the average. What if you're interested in the sum of the weights or the heights of the sample of the students? Then we would have, for every sample, we would have a sum, and the sums will make a distribution that is normally distributed, approximately normally distributed, with the mean of n times mu, which is the mu of the original population, and the standard deviation of the square root of n times the standard deviation of the population. And also, we could take samples, and instead of calculating the mean or the sum, we can calculate the proportion. Let's say you're interested in knowing what is the proportion of students in San Jacinto College or any other college that they believe that we should tax the rich much more, something like that. So you take a sample, let's say of 50 students, and count how many students believe in that. They say yes. Then that would be your x. So x is number of successes, and then you divide it by sample size and you get the proportion of that sample. If you keep doing that, then we will have a bunch of p primes, and the p primes will make a approximately normal distribution with the mean and a standard deviation. But what are those? Well, let's take a look at where P prime comes from. P prime is the number of successes divided by n. Now we know that number of successes is binomial. Remember from chapter 4, we have a binomial distribution, which is number of successes. And then we have, binomial distribution has a mean and has a standard deviation. So standard deviation of the mean of the binomial distribution is NP, n times the probability of success, and standard deviation is square root of NPQ. So what is the mean and standard deviation of the P primes? Well, it looks like we could just divide these by n, because that's what P prime is. P prime is x over n. So standard deviation of P prime would be NP divided by n. And the mean of it. And the standard deviation would be square root of NPQ divided by n. Now, if you do a little algebra, maybe cancel the n's, we get P prime, we get P, and then square root of NPQ, we can put the n inside the square root and square it. So it would be NPQ over n squared, and it gets canceled. One n gets canceled. And then we have P and square root of PQ over n. Now, of course, we don't have P and Q, so what we have to do, we have to use P prime and Q prime instead of P and Q. And doing that, it will cause some error, but we can take care of that in the next chapter. For now, we're going to just leave that P prime and Q prime. And you know Q prime is 1 minus P prime. So that's... So let's look at some examples. We're going to look at some examples in Newton Alta, but for now, let's look at two examples where the original population is known to have certain distribution. For example, here, the original population that we sampled from has a uniform distribution. Now we know under uniform distribution, the mean of the distribution is A plus B times divided by 2, and the standard deviation is this formula, square root of B minus A squared over 12. Now, to find the standard deviation of the x bars, well, all we have to do is take the standard deviation of the x and divide it by square root of n. So standard deviation of the x's divided by square root of n. And then the mean of the x bars is the same as the mean of the original population. So in cases where we have this situation where the original population is uniform, then we can do our calculations based on these two formulas. Now, what if the original population is exponential? Well, if that is the case, then again, according to central limit theorem, the mean of the distribution of x bars, or it could be sums, but then I have a different formula for sum, remember? So the standard deviation of the x bars would be standard deviation of the population divided by square root of n. But what is sigma for exponential distribution? Well, sigma for exponential distribution is just nothing but sigma is the same as mu, and mu is 1 over m. And m, remember, is the parameter of exponential distribution. So that would be easy because the mu and sigma are the same. For exponential distribution, these two are the same. So the mu of x bars would be mu, and the standard deviation would be standard deviation divided by square root of n. All right, now that we got the basic under control, let's go to Newton Alta and do a few problems from chapter 7. Here you go. That's 7.1. All right. Here it says the speeds of vehicles traveling on a highway have an unknown distribution with mean 66 and a standard deviation 7 miles. A sample with size 54 is randomly drawn from the population, and the sum of the values is taken. Using the central limit theorem for sums, what is the standard deviation for the sample sum distribution? Now, so we have to look at the basic ideas we talked about and see which one of those formulas actually works here, right? It looks like is this formula here, because we're talking about the sums, right? So the mean of the sums would be n times mu, and the standard deviation would be square root of n times sigma. So let's take a look at that. So here we have, so what is the mean of the distribution is 66, and what is the standard deviation is 7. Now since the sample size is 54, then the mean of the sums would be n, which is 54, times 66. So that would be the mean, which is that right there. Well, wait a minute. So using central limit theorem, so what is the standard deviation? Oh, we just want a standard deviation, we don't want the mean. Okay, well that's the mean if we wanted it. So standard deviation would be square root of 54, and don't forget to close parentheses here, and then multiply it by 7. And that is 51.44, which is this one right here. Right? All right. So let's do another problem. So it says, suppose weights of running shoes have an unknown distribution with mean 11 and standard deviation of 2. A sample of size 40 is randomly taken from the population and the mean is taken. What's the probability that the resulting mean is more than 11.3? Okay, now we want to be able to write on this. So what I'm going to do is I'm going to pick this so we can have something to write on. There you go. See if we can write on this. Okay, so we have a distribution, which is the distribution of the original distribution that is given, weights of running shoes. So it has a mean of 11. So the mean of this distribution is 11, and the standard deviation is 2. Now, a sample of size 40 is randomly taken. So this is sample of size 40. That's your n. And then what is calculated? Mean is calculated, so x bar. So that means x bars have a distribution of, the mean of the x bars will be, well, would be the same as the mean of the original population, which is 11, because we know the mean is the same. Now, the standard deviation of the x bars is going to be standard deviation of the original population, which is 2, divided by square root of 40. All right? So that's the way we are going to solve it. So 2 divided by square root of 40 will be the standard deviation. Now, what we are asked here is, what's the probability that the mean that we find here is more than 11.3? Now, 11.3 is about right here on this distribution, right? So we want to find the area to the right of that number, 11.3. So what we have to do, we have to use normal CDF, right? So you have to do normal CDF. Go down here and find the calculator. So normal CDF. And so the lower is 11.3. I forgot to put comma. Okay. And the upper, this goes forever this way. So it's infinity, which for us is 10 to 99, right? So we do 10 to the power of 99. And then what's the mean of this distribution? Was 11. And the standard deviation is 2 divided by square root of 40. And that is about 17 something percent, right? So round to 4 decimal places. So it's 0.1714, right? With 4 decimal places. Okay. Now, it says use this Z table. We're not going to use the Z table. If you were to use the Z table, you would have to convert the 11 point something, 11.3. You would have to convert that to 11.3 minus 11 divided by 2 over square root of 40, which is going to be Z. And then you would have to find the Z over here in the table, and then find the value, then subtract from 1. Because remember, this table gives the area to the left of Z. So if you find the value in the table, then we would have to subtract from 1 to find the area to the right of it. As I said, since we have normal CDF, we are not going to do this. But if you were to do it with Z table, that's how you would do it. But we're not going to use Z. We're going to use, oops, it's still there. All right, so we're going to use the normal CDF. All right, so that's that. All right, so here is another one. Let's see if it's similar. We move on. This is use the central limit theorem for means. Again, let's see if we can do this one more time. Let's create a table we can write on. It's a good area to write on. So here we have the weights in pounds of dogs in a city have an unknown distribution with mean 31. So the mean of the original population is 31 and standard deviation is 4. Now, samples with size n equals to 72 are taken, and what is calculated is for the means. There's a means here, so we're going to put x bar is calculated. Okay, now what is use the central limit theorem for the means? What's the standard deviation for the sample mean distribution? Well, the standard deviation of the sample means would be 4 divided by square root of 72. And that is 0.47. Let's get rid of that, out of that. 0.47. All right. Now here in class, I would say, do you have any questions? Of course, if you have any questions, you should come to the Blackboard Collaborate that I'm going to set up on probably during the same time that we would meet in class, but I'm working on that. I send you an email to let you know if that happens. All right, so here's another again Z table we are given, and what we are doing here is what is the probability that resulting mean is more than 264.3 points. Well, this is similar to what we just did. So I'm going to look for something that we haven't done. Pick in one more, and then I'll go to next section in 7.2. The heights of seasonal pine saplings have an unknown distribution with mean 279, standard deviation of 15, using central limit theorem for sums. Now this is for sums. What is the mean for the sample sum distribution? Again, notice that we are doing, let me do another whiteboard here. So we are taking from samples from a distribution of size 48, and then we are finding the sum, not the mean, but the sum. So the sums have a distribution. The mean of the sums is n times mu. So in this case, it would be 48 times 279, right? And whatever that number is. What is that number? 48 times 279 is 133 something something. There you go. 13392. All right. So let's do some problems from the other section, which is 7.2 there. All right. So let's read the question first. What is it that we are asked to do? It says, select the mean and standard deviation of the sampling distribution below. Now, it looks like we have a population here. A sociologist studying the number of years of education of students whose mothers have bachelor's degrees or higher. Data is normally distributed with a population mean of 14.5 and a population standard deviation of that. All right. So here, samples of size 55 are taken. So this is, again, sampling distribution of the means, right? So we got the formula. We have this is the original population, and then this is the sampling distribution of the mean. So the mean is the same as the mean of the population, and standard deviation is the standard deviation of the population divided by square root of the sample size. So let's do that similarly. So what do we have to do here? Well, we know the mean would be the same as where is the 14.5, right? So mean has to be 14.5. So this has to be correct. Now the standard deviation has to be standard deviation of the population, which is 2.5, divided by square root of 55. That's 0.33 something something. 0.34. All right. Let's look at another problem. All right. What is that one? Suppose a random sample of 150 Americans is selected. Identify each of the following. So again, this is mu. So let's make it a little smaller so we can see it. So mu is the original population, the mean of the original population, because it doesn't have a subscript, see? This mu has a subscript of x bar. So this is the mu of the sampling distribution of x bars, which is the same as that mu. So filling in this, you can get that one is the same as the mean of the population. We have it right there. That goes there. Standard deviation is right there. N is sample size. Now, the standard deviation of the means would be that number divided by square root of 150. And it should give you, so it should be 24,500 divided by square root of 150. And that's 2000.41. That's correct. All right, so let's move on. The number of times a human heart beats per minute is normally distributed with a mean of 92 and a standard deviation of 16. Well, if a cardiologist is examining a randomly selected group of 20 people for a new study on heart medication, select the expected mean and standard deviation of the sampling distribution from the options below. Now, sampling distribution of what? Well, we don't know, but look, the subscript here tells us that they calculated the mean in each sample. So that's what we're going to look at. We're going to look at this formula, right? Because they took the mean. So this is the formula we're going to use for the distribution. All right, so, well, you can guess it, right? So the mean has to be a 92, which is this right here. And the standard deviation has to be 16 divided by square root of 20. Is that what we get? 16 divided by square root of 20? Yes. All right. Let's do another one. If it's similar, we want to move on to do something more interesting. Select the expected mean and standard deviation of the sampling distribution. This is similar, so I'm just going to move on. Oh, celebrated already. All right, here it says a football recruiting coordinator believes it is unlikely for quarterbacks to score over 22 touchdowns. To test this, the coordinator randomly samples 33 quarterbacks from the last season. Now assume the number of touchdowns per season follows an unknown distribution with a mean of 19 and a standard deviation of 10. What is the probability that the average number of touchdowns for the sample is between 22 and 24? You may use a calculator or a portion of them. We're going to use a calculator. So basically it's, so we have to find the probability. So let's see how we go about doing that. Now, the mean of the distribution of force is 19 and the standard deviation is 1.41. Why is that? Well, you know why, because the mean, it says here, unknown distribution with the mean of 19 and a standard deviation of 10. Assume the number of touchdowns per season follows this. So this information here is about the population we are sampling from. Now, they sampled, the coordinator randomly samples 33 quarterbacks. So sample size is 33, right? So the question is basically, so let me draw a, so we can write on. So here you have a distribution, which is the original distribution, with a mu of, what was the mu? 19, and the standard deviation of 10. So now we take samples of size 33. Now we have a distribution that is the distribution of x bars. These are x bars. So the question is, we know the mean of this would be 19. The question is, what's the probability that the mean is between 22 and 24? 24. So we want to find this area here under the distribution that has a mean of 19, right? The mean is 19, and the standard deviation is, what's the standard deviation? Well, it's 10 divided by square root of 33. So what we want, we can do with normal distribution from 22 to 24, right? The lower and upper here. 22 is the lower and 24 is the upper. And the mean is 19 and standard deviation is that. Not 10, but 10 over square root of 33. So we put 19 here, comma 10 divided by square root of 33. There. So the answer should be something close to 0.04. And if you round and do some rounding with the z-table, you might get a little bit different answer, just a little bit off. But in this case, without any, so you see, instead of putting the standard deviation 1.741, we just use all the decimal places. Now let me do this again. This time, instead of a standard deviation putting 10 over square root of 33, if we round it to 3 decimal places, right, then the answer would be 0.04, maybe a little bit higher. You see, now it's 7, this was 7, now it's 9. So it's a little bit different when you do rounding. All right. Let's see if it's supposed to go to another problem. All right, there you go. So you see what they did, they used the table, so they did a lot of rounding using the table. Because once you find these two numbers, once you have the 22 and 24, you have to convert them to z and then use the z to find the area. So it's a lot of arithmetic work for no reason. We're not going to use the table, we're going to use normal CDF. Okay, here it's similar problem. It says after randomly selecting 52 closing stock prices from the social media company, what is the probability that the sample mean is between 155 and 166? Again, we have a population with a mean of 150 and a standard deviation of 25. So we want to know, if we take samples of size 52 from this population, what's the probability that the mean that we find is between 155 and 160? So basically it's the same problem. We just have to, it's very similar. Normal CDF, this time we want to go from 155 to 160, and the mean of the distribution is the same as the mean of the sample, which is 150. Mean of the population, right? That one. And the standard deviation is 25 divided by square root of And what's the sample size? 52. So that should be the answer. Let's see. So we got the mean and standard deviation. Yes, it's 0.073, right? If you round to that place. Now, if you find a problem on Newton Alta and you see your calculator and the answer that you get is a little bit off, you could press this feedback here and send your answer and say, my calculator answer, it's a little bit, your answer is off. It should be, and if it doesn't accept your answer, so if it doesn't accept your answer and counts it wrong, make sure you feedback to them, because you can use either calculator or Z. So if your number is a little bit off, it should accept it. If it doesn't, just press this feedback and send them a feedback. And send me an email and I'm gonna do the same. All right, so it looks like got chapter 7 under control. Don't worry about if there are no problems on the P prime here. That's okay. In the next chapter, we're going to talk about that. Next chapter, we are going to actually use P prime as well. All right. Now let's do one more problem here. It says that how much money separates the lowest 80% of the amount invested from the highest 20% in a sampling distribution of 10 of the family's real estate holdings. Use the Z table. Okay, so financial advisors analyzing a family's estate plan, the amount of money that the family has invested in different real estate properties is normally distributed with a mean of 225 and a standard deviation of 50,000. So how much money separates the lowest 80% from the top 20% of in a sampling distribution of 10 of the family's real estate? Okay, so let's take a, let me get a whiteboard here so we can talk about it. So what we have here is the original distribution that has a mean of 225,000 and a standard deviation of 50. Now we take samples of size n, which is 10, and now we have distribution of x bars with n equal to 10. So this distribution would have the same mean and would have a standard deviation which is 50,000, 1, 2, 3, 4, divided by square root of 10. Now under this distribution, the question is, what's a number here that separates the bottom 80%, right? 80% of the area here, and then 20% is there. So what's that number that separates the bottom 80% from the top 20%? And we know that number, let's call it K. So we're looking for a number K here that has 80% to the left of it and 20% on the right, under that distribution, right? So what is that number? Well, we can't use inverse normal, remember? We can't use a normal CDF, we have to use inverse normal. So what we have to do is this, we have to go to inverse normal, and then how much area is to the left of the number that we want? Did you say 0.8? Yes, 0.80. And then what is the mean of this distribution? 225, 1, 2, 3. And what's the standard deviation? 50,000 divided by square root of 10. So what's that number? $238,307.20. Well, all right, so 238,000. Well, looks like the answer is a little bit off from their answer. So that means if you do a lot of rounding here, let me make sure 22530 is 50,000 divided by square root of, yeah, sampling distribution of 10. All right, so everything we did was correct. Okay, well, if you do a bunch of rounding and convert to z's and use z's, well, the answer would be a little bit off. So you see the z value that I have is 0.84, right? So if you take that number that we found and subtract 225,123 from it and divide by the standard deviation, which is 50,000 divided by square root of 10, then we get 0.8416, which is correct. The z-score that we get is the same, right? It's a little bit off, but with 2 decimal places it's the same. But the answer is a little bit off. So if you put the answer here that you get and it counts it wrong, then just don't worry about it. Just email me and I adjust your grade for it. So the number that we found was 308,307.20. Now if he counts that wrong, then use that feedback and say my answer with the calculator was correct. There you go. Yeah, you see it counts it wrong. So you can use the feedback. It says, let's do that. Something not wrong. So my answer from the calculator inverse normal is counted wrong! Exclamation. There. And then we get your answer. Well, the reason is the rounding they did here. You see, if you do rounding and keep, rounding at first and then not at the end, then your answer would be a little bit off, right? All right, so don't worry about that, but if you understand how to do it, and the problem is just rounding, that's something we can fix. All right, so I think we got this under control. So next video is going to be on chapter 8. I hope everything is okay with you, and so I see you in the next video. Okay, have a good one. Take care.